discussed through the PowerPoint presentations, the videos, and the textbook readings. There were a lot of scheduling. Your discussion question just had you start listing them out so that you can have a list, and then later you're going to briefly describe them, and it's some way to just get a handle on it before your exams. So we did go over some exercises and questions. Here is one of the questions you had to do for your homework, and this is the answer that was given. Some of you didn't go as detailed with your answer, or your calculations were off. So do look in the textbook of how you do this calculation so you get this correct percentage. Some of you are off a little bit. But any questions on this exercise? And again, we understood what CPU burst. It was the time that it took for the processing of the process by the CPU. That will vary, obviously, depending on what computer you have, what application or environment you're using, and what's your purpose. But when we create a schedule and we have to come up with statistics, we have to start assigning numbers or having some kind of standard. Once we have a standard, or sometimes it's called a benchmark, that means we then can compare. We have to make some things the same so that we can make a comparison, and this way we can judge what is better or what is not. So that's when we start assigning numbers to CPU bursts, is allowing us then to make a comparison. Is it necessarily like that in the real world? Again, it depends on what hardware you're using. This could vary tremendously. So this is more in a theoretical format, so you can come up with some numbers to make a comparison. The processes we know vary, so we can't have everything vary, then we can't come up with any kind of comparison. So we're making something not vary, and some of it will. Okay, next question. This one was concerning preemptive priority scheduling algorithm. And again, this was listed in the book. You could look up this answer, and that's when you came up with the answers. First come, first serve, and last in, first out. So depending on how you're answering this, I did look for the straight answers as they're listed here, because this is actually how they are listed in the textbook. So it was a matter of reading the textbook, finding where the information was in the textbook, and then answering the questions. Any questions on the homework? Any questions? All clear. Okay, good enough. Okay, these were some optional ones. Again, I'm always giving you optional ones to help you then when you study for the exams. Some of these optional exercises may appear on the exam, so then you would already have looked at it and it'll be familiar to you. Or it might be similar and close enough that maybe you could know the answer. So which of the following scheduling algorithms could result in starvation? Anyone? We have an A here. Shortest job first and priority-based scheduling algorithms could result in starvation. So you had an option of choosing more than one. So the answer is shortest job first, which is B, and priority based, which is D. So the answers are B and D. Even though I'm having different ones, it's B and D. Again, you could read this in the textbook. There's more information on this. The reason why first come, first served won't is because it will be completed and the next one will continue. Shortest job first will switch the processes that are there. So if you have a long process and there's always short processes coming in, they will always jump over the long process. And if short jobs keep coming in, that long process will never get done. So that is why that's starvation. First come, first served. Eventually, all of them will be done. There is an order. There is an order of when they came in. There's a first come, and then the next one, and the next one. And they will get done eventually. It may just take a while. Round robin, same thing. This will not stop until all of them are done. A will not, A, first come, first served, will not stop until they're all done. Shortest job first, if there's always shortage, there's a long job, and then every time there's shorter jobs coming, forever, there's always shorter jobs, that long job will never get done. So that's why that will be a starvation. Round robin, this will continue until they're all done. So this will not run in starvation. Priority, similar to short job first, or shortest job first. What if I have a low priority, and then every process that comes in is always going to be a higher priority? Well, that means as long as it's processing, those higher priorities will always be done first. So anything with a low priority, as long as there's higher priorities coming in, will never get done. So the answers are B and D. Does everybody understand that? A and C will always continue till all of them are done. It will not stop. B and D, well, if something comes in that's always higher priority or shorter, then that long one or the one with the low priority will never get done. Okay, exercise this exercise. Using the window scheduling algorithm, determine the numeric priority of each of the following threads. Now this one, you just had to know how Windows scheduled their algorithms. What were the priorities? What were the numeric assignments to this priority? Again, they were in your textbook readings. So anybody have an answer for this one? These are the actual numbers. You had to come up with numbers here. You wanted to determine the numeric priority. It wasn't a matter of A, B, or C. It was what were the numbers. You had to come up with the numbers and do the calculations to come up with the numbers. And these are the numbers. So this would be a matter of going through, go back in the textbook and find out what numbers are assigned to which priorities and classes. And we know the numbers, the higher the number, the sooner it gets processed. So do look this up if you're not clear. These are the numbers. Okay, now this one, assuming that no threads belong to the real-time priority class and that none may be assigned a time-critical priority, what combination of priority class and priority corresponds to the highest possible relative priority in Windows scheduling? Again, you have to understand how Windows does its scheduling. How were the numbers set up? How were the priorities set up? So we will review this again when we do the midterm review, but if you have a chance, look it up. So high priority class and highest priority within that class. Numeric priority is 15. So maybe we'll do another exercise. Again, we have a lot of different schedules. This is just concentrating a bit on Windows. But when you're taking the exams, you're not going to have that much concentration on any one operating system. But this is just added here in case you wanted to know how your Windows works. Okay, consider two processes, P1 and P2, where P1 equals 50, T1 is 25, P2 is 75, and T2 is 30. Can these two processes be scheduled using rate monotonic scheduling? And you have a Gantt chart here that you could have created. So this was a little bit more evolved. It had you do a little bit more if you like doing that kind of stuff. And then to illustrate the scheduling of these two processes using earliest deadline first, scheduling. So this is what the answer will come out to. If you want to go back and revisit it and calculate it, please do so you can get a better understanding. Okay, explain why interrupt and dispatch latency times must be bound in a hard real-time system. And here's the answer for this one. So I'm just going to go through these, offer you the answers. You can take these answers and then review it and look it up so that you understand the answers. And if you don't, again, please bring them in the discussion forum so we all can look at it. I'm assuming you are getting it, or after you see the answer and look it up, you will get it. Okay, the only thing is because week 4 we have a programming assignment, and I kind of want to get you as much time as possible on the program and what we're going to be looking at. So if you have any questions on week 3, again, bring them into the discussion forum. It was a lot of statistics and calculations, as you mentioned. These are just some example questions. And hopefully you'll just have the general idea when you're studying for the midterm exams. You don't necessarily have to get that detailed at this time. Does that make sense? Or are there any questions you want to address right now? Yeah, general, yes. Again, just know all your topics, know your definitions. Use the questions I'm offering you as well. There'll be a mix. I mean, there'll be a mix of easy questions, medium questions, and hard, but it'll be a mix, so it's not all one kind. So to get the general idea, you will be doing fine in the exam. A lot of this is detailed. I know this is making you an operating system expert rather than just taking a class on operating systems. People it takes them years to get that good on operating systems. We can't expect you to get that much of an expert in just how many weeks we have for this class. But do know, if you like it and you want to know more, go ahead and do so. You'll just be, that much. If that's something you have a passion for and it's something you like to do, then by all means, you should learn more. Systems programmers it's a hard field, and it does pay a lot more money than regular stuff because it's harder to do. But it takes a lot of time to understand it. Right. Again, keep learning after school is over or after a class is over. You still can keep learning, and you sort of have to keep learning because things change in the computer field or IT profession. Things change, new technology, new strategy. So it's good to belong to an organization, and every time something changes, you can't go back to school and take a class. So you kind of have to learn how to learn on your own. And this is where you're in the workplace, you'll have other teams or colleagues that you can work together with and learn about, or just research on the internet when there's new stuff that comes out, and look at the tutorials so that then you can learn about it. Because things change all the time. Just even while you take this class, there'll be some things that'll change. So it's a matter of, if you like it, then you don't mind, you know, researching and learning about it even after the class is ended. Okay, so week 4, we're going to talk about synchronization and deadlocks. And that is, if we have many processes we want to do at the same time, how do we make sure we don't mess them up or we don't confuse them? I did mention this before. We have strategies for scheduling for one thing, but now we have it when we're going to be doing processing with shared data. We did talk about it. Sometimes they share the data, sometimes they don't share the data. This is in your program. Some programs have different classes, and typically it's better to share data because then you won't need so much memory when you're going to do a program. We have to keep in mind that when anybody runs a program, there's a lot of things running, and we don't ever have a problem with the user always running out of memory, and then they can't run the program. So you want to make sure that your programs are running and that you can then utilize your resources the best way possible. And one way is sharing the data. But when you share the data, similar if you have like a multi-user database or a multi-user spreadsheet, very similar. If somebody is updating the data, we can't have somebody read the data until the new data is there. So they have to be locked out until the new data is there so that somebody then can look at it. Or think of it this way, if you have a database or you're making a bill for a customer and the customer has an order, well, you can't send out the bill before you have information on the newest order. So there has to be some way to know that you have to wait before you send the customer the bill so that all their orders are there and on the bill, and then the company gets paid for all the orders. So these are strategies that are used. Mutual exclusion is a way to do this. Operating systems must support synchronization among processes. Synchronization means when one process is allowed to execute when the other one is done. They have to be synchronized. If there's something that the second process needs from the first process, then you have to synchronize them. You have to make sure that that first process is done before the second process continues. It can't start before and it can't start in the middle. It has to only start when the first process is done. So it's putting it in order. Mutual exclusion locks and semaphores have been used to solve various synchronization problems and can be implemented efficiently. So you're going to be learning about these locks and these semaphores. This week you'll have to pay special attention to the code because we are creating a program for this week. So it's very important to start early. Reading the textbook, do your reading and look at the videos and look at the presentation so you understand the logic, because you will have to use logic for your programming assignment. So start looking at the logic now. So we're going to look at there's different strategies, how this is done, depending on what you're working with. Here are some of the topics for Chapter 6. We're going to look at the critical section problem, Peterson solution. These are all solutions as to how to do this. How to synchronize hardware, mutual exclusion locks, semaphores. So understand at least the critical section problem. Understand mutual exclusion locks, and semaphores. If there's anything, those three are very important for you to learn. Then chapter 7, what happens if there is a deadlock? Say two processes are trying to get the data at the same time. Now, a lot of these strategies are also used in networking. You think about networking, say I want the printer and you want the printer, and we're sending our request at the same time. What does the network do? Give it to you or give it to me? If we're both trying, it can get stuck, and that's called a deadlock or a collision. So there's another area. You did mention you're learning some networking or have, so this kind of be an application of some of these, not just in processes. Again, a lot of strategies you learn in this class apply to a lot of situations, not just operating systems. So it's very important that you understand it, because you may run into it when you're doing something else. If you're doing any networking, if you're doing any multi-user applications, all of these apply. It's a matter of you have a process, or you have a network, or you have a person. But they all run into these kind of situations. So do take the time then to understand it now. It'll make you better no matter what area you're going to do any kind of programming or administration. Okay, so deadlocks. A deadlock can occur only if 4 necessary conditions hold simultaneously in the system. They have mutual exclusion. There's a hold and a wait. No preemption, meaning nobody can jump ahead of anyone else. And there's a circular wait. In other words, they kind of just go around the circle to see who should get it next or not. So to prevent deadlocks, we have to make sure maybe to release someone so that they can get access. That's a common strategy. So we'll look at those as well. So we're looking at methods for handling deadlocks: prevention, avoidance, detection, and recovery. The best is, of course, write your code so the deadlocks never occur no matter what. But unfortunately, sometimes code is not written that well. So then we have to figure out a way, in case it happens, what do we do? Any questions so far? Any questions? Okay, so this is actually very, if there's any important information about process management, this is one of the areas to really concentrate on. Okay, so for the class, what do we have? We have some readings to do, chapter 6, chapter 7, and also there's an article. Now this article will be part of your discussion question. You will read this article and then you will respond to it in the discussion forum. So instead of doing a normal discussion question, you actually have an assigned article to read. This is too much. I know there's a lot of information here, but do the best you can. Again, work together in groups. I think that would be the best strategy. Can we stop for 1 week? No, everything is due Saturday, yes. But start early. Maybe do the article by Wednesday, but the article, and then start reading now as soon as you can. I don't have any say on the deadlines. The deadline, there is a curriculum development team who they set up the deadline, and I can't change them. So we'll see. Again, I'll be giving you information to help you. And remember, this is only 1 week. So you won't have all your grade is not on this 1 week. No, I can't skip it. No, we have I have rules and policy I have to follow. So I can't do anything different than what I'm supposed to do. Just like you have rules to follow, I have rules to follow. Okay, so the discussion question. You will read this and respond to it. You will do these exercises at the end of the chapter 6.1 and 7.8. This is the 6.1 question. It's referring to race conditions. And then this one. This is looking at deadlocks. Then chapter 7 is about deadlocks. Chapter 6 is about synchronization. Now the programming project. The sleeping teaching assistant. Now what will help you is to look at the code that's in the chapter. But take your time. You really just do some of it every day. You have to do some work every day. So as to how much, that depends on how your day goes, but don't leave one day alone. If you have 7 days of work every day, you will be all right. But if you only do 3 days of work, then it's going to be too much. The only way to make it so it's not so much if you do a little bit every day. So try to do that. I did mention from the beginning of this course, you have to have a daily routine to do this class. And at least you are coming here, so the information here will be helpful. Okay, so this is your first programming project. You will do it in Java. But please work together on this and bring your questions to the discussion so we all can answer your question. Some of you, some of you may have the question, but you didn't ask the question. But if someone else asks it, then you will get the answer. So bring everything to the discussion forum. We all are working together. You're not alone in doing this. Again, there's two things here. Do something every day, and no, you're not alone. We all can work together. Just start early in this week to work together. Yes, I'm going to give you help right now. Give me a chance. We're not done yet. But you all could work on it together. Go in the discussion forum. I won't know what you're going to have problems with unless you ask me the question. So put it in the discussion forum, and then I will give you the help that you need as you're looking at it. So we will work on this all together. So you can do it because we're all together. We will help each other. I will help you, and you're all going to help each other. So really, it's not going to be as bad as you think. It just sounds bad, but it's not. If we all work together, and if you do something every day about this chapter, read it every day, something. Okay, the sleeping teaching assistant. Okay, this is the description. Now, one thing, when you are doing a computer program, I don't know how much you did in your Java courses or in any other course, but really planning is the most important part. Planning and understanding what are the steps you think the computer should do so this is done. So don't even think about Java code yet. Just understand the logic so that this is handled. You have a teaching assistant. So that means, okay, we have a teaching assistant, and this assistant has some kind of characteristics. And it helps undergraduate students. Again, we have another item or object called a student. Okay, what is all about the student? So just start identifying the parts that you will have to deal with when you write it. But you're not writing it right yet. You have to understand it first before you write it. Once you understand it, really then writing the program will be very easy. It's understanding it that's challenging in the beginning. But once you get the hang of it, then there'll be no problem because you'll know how to plan it first and then go write the code. Once you plan it, if you plan it well, then there's no problem when you create the program. Okay, so you know you have a teacher assistant, you know you have a student. Okay, well, describe them. You know, start just taking notes. What does the teacher assistant have to do? What does the student have to do? Well, we know the teaching assistant is supposed to help the students, but can only help one student at a time. Think of it as processes. Okay, a teacher assistant can only process one student. It's like one program. Can only do one instruction at a time, one student. And then there's 3 chairs in the hallway where the students can sit and wait if the teacher assistant is helping a student. So we already know things that we have to keep track of. We have to keep track of the teacher assistant and if there's a student in the room. If there's not, then what do we do? If there is, then what do we do? So just start looking at the kind of actions that have to happen, and that'll help get the logic for the program. What if there are no students that need help? What happens to the teacher's assistant? They sit and take a nap. And if a student comes and finds the assistant sleeping, they got to wake him up. So right away, just kind of jot down, what are all the possible scenarios here? Well, we have a teacher assistant with no student in the room and no student in the chairs, so the teacher assistant is sleeping. Or we have a teacher assistant that has a student in the room and no people in the chair. We have a teacher assistant with a student in the room, one person in the chair. We have a teacher assistant with a student in the room, 2 students in the chair. So just start looking at all the possible combinations. Once you understand all the possible combinations, then you're going to look how to move from one combination to the next combination. So that's definitely what you will start doing now. Is just put it out. Again, teacher assistant, no student. Teacher assistant, 1 student. Teacher assistant, 1 student, some chairs. Teacher assistant, you know, just go down the line, all possible combinations. And that'll be your great step to help you then to figure out what to do next. Okay, so that's really the first start to look. So it doesn't sound that bad, does it? No, you know that already. All the different situations that it can happen. Once you know all the different situations that happen, then you can start representing them in pseudocode or programming statements or step-by-step sequence. Once you find out all the combinations, then how do you put those combinations in order? How do you make it go from one combination to another combination? So there's sections in 4.41 on how to use p-threads and also 6.9.4. Again, you already have some example code in your textbook, so that's why, again, it's important that you read your textbook and look at the code. If you have questions, ask in the discussion forum right away. I will be monitoring it, and your classmates will be monitoring it, so that you can get the answer right away. Don't wait until you have so many questions you're confused. As soon as you have a question, right now we have pseudocode. We're all deciding that now as to see if it has to run. It would be great if you did. Yes, it would be wonderful if you actually created a program that runs and does what it has. However, there may be some other options that we will allow you. For example, full credit would be everything running. Maybe partial credit. You give me some code, but it doesn't run, but you at least tried it. And then pseudocode. So there'll be different levels and different options, so you still can get some credit. And remember, this is just a small portion of your entire course. So we can do it where you can get some credit or all credit. depending on how much time you have and how much time you could devote to do this. So here's some strategies. Make sure you have Java, and then an integrated development environment. And these are the steps, again. These are the steps you need to follow. These are basic programming tools. So if you're not sure how to start a program or what to do about the planning, these are some steps you need to follow, just like I did. First thing first, look at all possible combinations. That'll start giving you an idea and allows you to see patterns. Once you see patterns, then you know patterns can be put into programming code. So again, make all the combinations. And then once you make the combinations, you'll know then which parts you can have the computer automatically do. So determine your program scenario, similar to what I did. What are your input values? Well, you're going to change it. We know you have one teacher assistant, and you know you might have 0 student or 1 student in the office. And then you may have 0 students or up to 3 students in those chairs. So those are your values right there. How many students total can you have? Because what if there's a student in the office, all the chairs are full, and a student comes in? What do? They can't go to the office, they can't sit in a chair. So what they could do is they could just do some other work. Okay, if we go back to this one, this kind of describes things that'll happen. So student threads will alternate between programming for a period of time and seeking help from the TA. So in other words, they're going to go off to the computer lab and start programming. And then you're going to decide, okay, you're going to give him a time. After 5 minutes, he's going to come back and check again. So these are things you're going to set up. You're going to set up the numbers as to how things run. You will say, okay, for 5 minutes or 5 seconds. What are your output values? What are you going to show? What are your processing components and logic? How are you going to test your program? So again, just start writing down the different combinations. Start working on your class diagrams. In other words, what are things about a teacher? What are things about a student? Create a flow chart if you know how. But it's just a matter of starting to organize the steps that you want your program to follow. In order to know the steps, you have to write out all the combinations, and then you're going to see the patterns. The patterns then will help you then with the flow chart and the pseudocode. So again, I want you to work in groups, analyze the program scenario, bring everything in the discussion forum. We all can work together. Write down what are the points you have to address. Review the code in the book and determine which ones apply. There's a lot of code there, but you have some sample code that you will use exactly. Research the internet for example solutions and code in Java. I did offer you on the announcements page, you see 3 videos. Those are some various solutions or examples, illustration of some of the items that are discussed in this chapter. We have the dining philosophers, we have the bankers algorithm, and readers and writers. So do any of those, are they similar to what we have to do? If they are, then you're going to have the same kind of logic. Now, I do here, now I'm going to offer you as well. This is, the slides following here is the actual program code for this programming assignment written in the C programming language. So, this, from the book is C. You need to use Java. So I'm giving you the C programming code, and then you will convert it to Java. But first, let's first start in understanding it. Okay, so we have it here. See, I told you I would give you some help on this once we get used to it, but this is a good help. So this is all the C code for the same program, and you do it. And also here's some other, this is actual Java code. So if you want to look at some Java code, it is here. So you can look then how to write your Java code. And then the slides following here are example optional exercise questions. So something we'll talk about next week after you review it, but this will help you learn aside from the assignment. Okay, so again, let me go back to our strategies. You have the code here. Now it's getting easier. I told you I would help you. Not only that, you're going to have you're going to understand C as well as Java when you're done with this class. So again, work in groups, analyze program scenario, write down your points. Write a flowchart. If you haven't done a flowchart is a very good way to understand logic. And it's a good way to make sure you don't forget anything in your logic when you start have to graph it out. So do look at the information. If you haven't, have you created a flowchart? Have you done this in any of your previous classes? Anybody? Okay. Yes, good. Okay. Again, when you do any kind of program, the most important is not to just go sit in front of the computer and start typing in code. That's the only way to make a bad program that probably has a lot of errors and won't work. Unless you've been programming for years, and a simple one you can do, actually, even if you're doing a simple one, somebody who programs a long time, they just have all those things in their mind. So that's why they could write the code. It's very important to use programming tools for the design before you actually do any coding. So that is the way then to make sure you don't miss any steps, to make sure everything is represented. You have to plan it first. When you're looking at a screen of code, that's not going to help you in getting the full picture. So you have the C code. Use that C code, maybe make a flow chart so you understand the logic, or write down the steps. Write down the steps you think for that scenario based on the description of that scenario. I mean, again, you have help here as well. Oops. This is help as well. And it tells you, look at 6.9.4. Look at 4.4.1. That'll help you understand the C code. These are the logic. So kind of make sense out of this logic. Put it in the flow chart. If you put it in a flow chart, one thing about a flow chart in programming code is every symbol in a flow chart matches to one line of code. So if you create that flow chart, you already are automatically pretty much writing your code. You don't have to put the code in those symbols in the flow chart. You can just write it so it's simple to understand, like a little sentence. But then later, then it's very easy. When you do that flow chart, you have every step or line of code you're supposed to have, and then it's just a matter of taking that information and actually writing the code. So first start planning out the scenario, write it out, put it in some order, come up with all the possible combinations, because you got to make sure all those different combinations, you don't miss one. You may have a program that runs, but if you miss a situation, then it's not running like, it's not giving you the results you need. So go through these steps. Again, you can work in groups. Go through these steps. Understand the code in the book. These are programming strategies. What's your input values? How many teacher assistants are there? How many students are there? How many students are going to be waiting? How many students are going to be in the office? How many students are going to be in the computer lab because they can't sit or they can't be in the office? Those are pretty much all your scenarios. And also, if there's no student and nobody waiting, the teacher assistant sleeps. What are your output values? Well, you can determine what kind of output values you want. What do you want to show? Well, you can at any one time show, is there a teacher assistant working with a student, or how many are in the chairs? You can give some example scenarios in your output. But the most important is the logic. How are you going to handle this? If a student comes and a student wants help, so if a student wants help, you have these various possibilities. The student wants help, the teacher is sleeping because there's no other student there. The student wants help, but there's a student in the office. The student wants help, but there's only one student waiting. So that means they can sit down. The student wants help, and there's two students waiting. So the student can sit down. The student wants help. All the chairs are full, so the student has to go to the programming lab. So write these steps. Again, once you write down all these steps, that's how you're going to understand how to do the logic for your flow charts. And then I mentioned from the flow chart, you right away have your code. So again, work together in understanding this. You have the C code, create a flow chart for this, and start looking at what's the comparison between C programming language and Java. I did offer you some links down the road. I do have some videos in the classroom. I do have some links here for Java. Start looking at some Java code, source code that's similar, so that it'll help you with the logic that you would write in Java. And then here's some extra exercises that you can go through to help with understanding week 4, chapter 6 and 7. And these are the sections to look at, similar to what we did last week. Okay, any questions so far? Do we feel better now about all this work? You have some help with the programming assignment. Please ask each other help in the discussion forum. Work together on this. Ask your questions right away. Don't wait till the last minute. Start now. Ask your questions right away. Don't wait till you have so many questions you're confused. Yes, I'm hoping this will help you. We have such limited time together, so I'm trying to give you as much as I can. And it's better, again, it's better if you put in the discussion forum your questions than emailing me. Because if you put it in the discussion forum, everybody can see it. Everybody can maybe give the answer or get the answer. So to help everybody. And then as for the first, start with these steps first. Of course, if you do it in Java and had it run properly, then you do get full credit. You will use these data structures as they are used in Java. Good question. Start looking at the Java example code, and then the different data structures that Java offers you, you will see. Again, you're going to compare it to your C, but you have to use what Java offers. So compare the C programming language program that you were given and compare it to some Java example code, and it will tell you right away what to do. It'll be an easy way to do that. So we'll talk more about it on Wednesday. I know, but you're going to understand the logic. Then you know your Java. Then here you go. You're going to be able to figure it out. When you look at your C, you'll be able to figure out what to use in Java. Good questions. These are great questions to ask in the discussion forum so we all can work on it together. But you know you should have a teacher class. You will have a student class. So what kind of information do you need to keep? You may just use an array. If you use an array, then you're going to keep track of those chairs. You want to keep track of those chairs that are in the hallway. You want to keep track of the chair in the teacher's office. teacher assistant's office. So you're just going to know if it's full or not full. So you can have an array, and you can fill it with a 1 if a chair is full, or a 0 if the chair is not full. So an array would work fine. And then you could use counters to go through the array. Did you learn about arrays in your Java class? Anybody? Do you know what an array is? You do know them. Okay. I think that would be the simplest structure. Because remember, you got to always check to see these chairs. If the chairs are an array, then you could use simple loops to determine if a chair is full or a chair is empty. And the way to do that is to see, is there a 1 or a 0 in the array spot for that chair? So there's an example data structure, and then your class construction for your teacher and student. So did you create classes in Java? For class construction, you want to use class diagrams. There you go. Okay, so you did. Okay, so really, see, in the beginning of this session, you thought you can't do it, you don't want to do it, you don't know how to do it. But really, you do know how to do it, and you're going to be so proud of yourself when you do it. Just take it. Don't get overwhelmed with everything. Just take it in one step. And follow the strategy steps I gave you to do it one step at a time. Really, you will understand this. And also, when you start looking at the different codes, really, when you start seeing that code, it'll kind of, the light bulb will light up, and you'll say, oh, I understand this. And it just sounded more complicated than it is. Anything you break down into simple steps makes more sense, and it's easier to handle. If you look at the big picture, then then it looks overwhelming and kind of scary. But just take it one step at a time and know we're all together on this, and we're all going to work on this together. So I'm glad you're getting sense out of it. Again, post questions in the discussion forum so we all could see the questions and we all can see the answers. And I will give more links. Look at the links that I give you already. Look at the videos that are on the announcements page. It really is fun stuff, and it's something that once you learn now, you will be able to use it again and again and again. So you're going to know it so well that it's not, you don't even have to think about it. It's just kind of scary the first time through. But the more you start looking at the different logic and flow charts, make your own flow charts and logic, it'll be 1, 2, 3. And then again, put your questions, especially any questions you want me to answer on Wednesday, get them on there now so I could talk about it Wednesday. You are quite welcome. And thank you, my wonderful students. I know you're going to be able to do this. You're also smart. I told you that from the beginning. You're very smart. You're very dedicated to your education. So I know you'll have no problem. It's scary in the beginning, but once you start doing it, you'll have no problem. Believe me, when we come to the next programming assignment in a few weeks, you're going to get it 1, 2, 3, and you're going to say, wow, I can't believe I was scared for that first one. Now it comes to me so easy. But again, ask your questions right away in the discussion forum. I will give you more resources and links. You have the code to start from, and just start understanding it. If you don't understand it, then ask the question in the discussion forum. Okay, and with that, I have a good day, and I'll see you Wednesday. Actually, I'm going to see you in the discussion forum because you're going to start offering your ideas and questions in the discussion forum, and we're all going to work together. We're one big happy family. So have a good day. This is recorded if you want to see it again, and I'm going to put the slides here on the discussion forum so you can get the slides, and then if you want to see the recording again, you can.